So, welcome to my dear student. Today, we are going to discuss about the liquid droplets simulation. So, normally, uh, one of my student he will be working on cooling tower efficiency enhancement. So, there the water droplets it will be uh, passing through the fill material, and we need to know the nature of the flow, and later on uh, some other physics it will be added related to heat transfer. So basically it is a complex problem with complex problem of water droplets simulation with conjugate heat transfer problem. So we will be using COMSOL multiphysics. So the dynamics and the governing equations behind the liquid droplets that I will detail later in separate video. So today in this video, just we are uh, going to learn how to simulate it. So basically we are trying to formulate the problem, and we can add uh, the other boundary conditions one by one when we'll be knowing details about it. So for um, computational simplicity, I'm using 2D model. Okay, so it's a multi-phase flow, and it's a two-phase flow with level set. We are considering the streamlined flow. Okay, we are adding the physics. So basically this problem is for simplicity I'm considering that uh, in the oil, in a, say there is a container, and inside that some water is there, and inside the water some uh, oil droplets are there. Then how it will behave? This will, due to the movement, the flow of the droplets will be due to gravity. Okay, so we are considering it's a transient analysis. Definitely we can do it with a 3D model, but in that case, when we'll be doing the actual problem, so we'll be working on the working in a cluster system so that the solution can converge quickly. Okay, so now I am going to the geometry, and I am taking a rectangle. Let the size is 3 by 7. Okay, then arbitrarily I will be creating some oil droplets. So the let the radius is 0.25, and it will be somewhere here. So this is one liquid, means the oil droplets. Another we'll use say 0.12, and this will be 2, and the x will be, say, this will be 3.5 somewhere. Okay, we'll use another one, say it is uh, point 3, and this will be somewhere in, say, 2.5, and this will be in, sorry, 2.5, and this will be in 1. So this just arbitrarily I taken, and in the top there will be another layer of the oil. So the width I will take, it is same as 3, and the height is, say, 2, and the center, this is 7. Okay, so this is my approximate geometry, or we'll take slightly less, 1 point, let us take 1.5 or 1. Okay, now we'll add the material. We'll go liquid and gas, and here it will be liquid, so we can take material. This is transformer oil, and another we can take, it is water. Okay, so the transformer oil, it will be this, sorry, and this, let us, another one, select this. Okay. So sorry, so this is it, or the water, and this will be the water. Okay, now in the laminar flow, will, because here we will include gravity. Okay, and as there will be no inlet and outlet, so definitely we have to define one pressure point constraint, that I'm selecting this one, and the initial value, let us take, so this will be the uh, fluid 1, it will be the oil, and fluid 2, this will be the water. So this one, the water, and this will be the material, means the oil. Okay, and here the fluid 1, this will be in the transformer oil, and the fluid 2, it will be the water. Okay, and the weighted wall, we'll consider this one. Now we'll go to the mesh, and we'll go to the steady. Let us do it for say 3 seconds, and let us see the result. definitely it will take some time. As I told, here you see the degree of freedoms are around 15,000. So definitely it will take some time. And as you know, it's a transient analysis. So definitely this will take more time. So for the time being, I am pausing till the solution is getting. Okay. So the solution get converged, and we'll see how using the animation tool, we'll see how, you see. So we cannot see, it is very fast. So let us increase the frame and play again. Now you see that liquids, these are going, and finally it is. So if you increase the time, you can see the how it will be moving. So this is a very basic problem. I have shown you how to simulate uh, water droplets. So you can consider, instead of this, uh, instead of water, you can, where I say it is a, you can consider any porous media like air, and the water droplets are falling from the top and accumulating at the bottom. So how it would be? Now you can, because the module which is to be selected and how it is to be, boundary conditions are to be applied, I think you have understood that, and now you can do by your own. So thank you so much. Thanks for your patience.